Question 6. So, we're graphing x squared and x minus 1 on the same set of axes. Make sure any points where g of x equals 1 are clear. So, I mean, you should be able to graph x squared fairly quickly as well as x take 1 fairly quickly. So, let's do that. X squared's all positive, by the way. So, I'm going to put my axis kind of give myself more room in the positives. And so if I graph x squared in green, 0 squared is 0, 1 squared is, there we go, 2 squared is 4, and I'll have 4, 3 squared is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and there we go, and so that's y equals f of x, which is x squared. And now I want to put one in for x minus 1. Well, if y equals x, then I've got -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, etc. I'm going to wish that I'd done these in thinner pens because I'm about to show you something. So let me redo that. See? I can see where they meet. Okay, make sure any points where g of x equals 1 is clear. So this is where g of x equals 1, and it's the point. Oh, I totally stuffed that up because it wasn't g of x, it was x minus 1, so I've just got to move it down 1. There I go. That one actually hit it all. So this is the point 2, 1, because, you know, if y is x take 1, well, 2 take 1 is 1. Cool. Mark the zeros of f of x times g of x, which occur where f of x equals 0 or g of x equals 0. So f of x equals 0 at the point 0, 0. G of x equals 0 at the point 1, 0. By noting the signs of f of x and g of x, and hence the product of y equals f of x times g of x, add the graph of f of x times g of x to your diagram. So what that means is f of x times g of x is going to be 0 here and here, and it's going to be positive. You know how we have a positive times a positive is a positive? So it's going to be positive wherever both of them are positive, which is kind of once we get up here, it's going to be positive up here. And negative times negative is also a positive, but f of x will never be negative. So negative times positive is negative, so it's going to be negative kind of down here. But let's actually do the easy bit, which is by multiplying the numbers wherever we can. So for example, when x equals -1, we've got -2, we've got +1 times -2, which is -2. So this was +1 and this was -2. +1 times -2, -2. X equals -2, we've got +4 times -3. So that goes all the way down really quickly to -12. Like, yeah. And we know we're going through 0, 0. 1 times 4 is 4. So we're going to get a really weird thing happening, which is fine. Wait, how can it do that? unless, because it's dual and negative times positive, so this one's not actually going to go through. It's going to touch the 0. Yeah, it's going to be like that. Cool. And I'm going to regret going over to the next page, so let me cover that up. So that's what that'll look like. Oh, sorry. Look, don't overcomplicate it, just multiply the numbers wherever you can.